So let's just start then. So we'll see if some time remains. Otherwise, next time we can have some demo sort of also. So we'll start here. So basically, first of all, before moving into Cassandra, so we'll just spend some time on the column-oriented databases. So basically, if you see in relational databases, we have a relation across the tables, and their data is also persisted in terms of entire rows, where each row is persisting its in entirety, and then the column is there. But when you comes to the column oriented databases, so over here, uh, each granularity of storage will be the column name comma column value pair. So if you see this brand comma Samsung, model ID comma Galaxy X6, and so on is other details. So what happens with this is the storage is not wasted. If you store there might be columns for which you are not storing certain values, or some columns which are not having data for a specific column value. So those sort of storage is not wasted here in this particular storage system and column oriented. And coming back to the Cassandra, before coming back to the Cassandra, so over here, like each entire collection of columns, which we will call a row, a collection of column value pair, which we call a row, will be represented by some identifier. So that's the memory footprint sort of you will mental model you can visualize for a column oriented database. In the relational database, you can just visualize it as a tabular format, correct? So coming back to the Cassandra, first, like what Cassandra provides to us. So Cassandra basically is sort of a column oriented database, and it is a decentralized architecture. And what I mean by decentralized is basically there is so whenever any cluster is existing there, then basically in any setup you will have some node, master node. Like if you take example of Elasticsearch or someone, where typical architecture will be some node will be entertaining a request, and then that node will be spawning that request across other working nodes, and then get the data, and then basically coordinate, consolidate that data and return it back. But over here, what happens is there is no leader in this Cassandra. So if you want to visualize it, you can visualize it as a ring. Basically, a ring you can visualize where a lot of nodes are placed, and in that node, in that particular ring, whenever request come, any node can act as a coordinator node. So that coordinator node is like equally probable anyone can act as that. So there's no leader in this particular architecture. This is like a decentralized. So if master node fails, or if I say if any specific node fails, then they will have
Amit, you are not audible. Is it only for me?
No, it's happening for me as well. Amit, you're not audible. You can hear us.
Chat में लिख दो यार.
Can you guys hear me?
Yeah, we can hear now.
Cool. इलेक्ट्रिसिटी चली गई थी. Let me you guys can see my screen.
It's blank
Yes.
screen coming.
Give me a minute. I don't have to start the recording again, I guess so.
No, it's still recording.
Got it. Cool. So you guys able to see the slides?
Yeah.
Yeah. So I was coming back to the decentralized one. So over here, what happens is any node can act as a coordinator node. So in that scenarios, it is very tolerant to fault. Any master node going down in like a Elasticsearch, it will basically expose the availability of that particular cluster setup. So that is one advantage here. Then again, it is elastically scalable. You can easily add up any node there. Because of that ring sort of setup, you can always visualize. Whenever you can think of Cassandra, just think of a ring where multiple nodes are placed. I'll come back to that, how that is useful in later slides.
One question.
Yes, yes.
So when you're saying that there is like any of the node can take the request, so is it like some mechanism to decide the node, like consistent hashing or something, or it happens like randomly?
Get back to those in later slides. How basically
Okay.
read and write request identity. So that I'll cover. Then again, basically scalability, availability will be high. Then comes the consistency part, which is sort of a tunable here. I'll cover that in the later part. So moving to the next point. So one ring is acting as a data center. So that's what, like, if you want to visualize a data center there. So our entire data center can be visualized as a single ring where multiple nodes are placed. Similarly, you can visualize another data center in the same way. So there is a support of secondary indexes also. So secondary indexes is like the way we store the uh, basically our data in any node is driven by our primary key. Whatever is not covered by primary key is covered with the help of secondary indexes, but secondary indexes is limited to a node. It will be applicable within the node itself. So that is not highly recommended to use secondary indexes. It degrades the performance to not, I'll not say, it depends on the query pattern. It can degrade it also, and the storage also is overhead is also there. So usually it is recommended to uh, uh, cover your query patterns using primary keys. So one better thing about this is that there's a SQL which is exactly same as SQL. So you might not find any difficulty in interacting with the Cassandra if you are already comfortable with any RDBMS. And again, the standard part that it is not bounded by any table schema. So few of the limitation is key. If your data is just can be easily supported with the help of a single node, then it is recommended not to go with the Cassandra, because it will it will be the over engineering part there. If you can just easily with a single node you can serve everything at a scale, then there are better and cost effective ways to go ahead with your system. And also wherever you need instant read and write, there also it is not recommended much. But again, the consistency you can tune to any extent you want. And again, that it's not a asset compliant data structure. Now coming back to the specifics of Cassandra, so there is a concept of a column family, and key space. So column is basically the thing which I was specifying here. So this particular brand, comma Samsung, this is the column pair where you have a column name and column, basically column key and column value pair. So that is available to you. That's what column is for you. And column family is a collection of one or more columns. So column family, just for the visualization purpose, you can always visualize it as a table you have. So just like a table, you determine your column family, and while determining your column family, if I show, mm, yeah, if I show this, this is basically your column family you are determining. Ki, this is my column family, and it will contain these all columns. And basically, within the column family, there will be a primary key you will determine. So every column family must have a primary key, which will be uniquely identifying the rows within it. And collection of multiple column families is called key space. So if you see here, this part UPS dot, so this is like a key space user profile service. And this key space, if you want to take a visual picture, then you can visualize it as a database you have. So just like if you have any database, if you just open any of the database client, you will open a database for user profile service, and then within that database, you will have multiple tables. So similarly, in UPS, key space is acting as your database. And once you enter into a key space, first you enter into a key space, then you can explore any of the column family, which is acting just like a table. So coming back to the primary key now. So from now, the main part will start. So this primary key, which we were talking about, which is basically the identifier, or which is basically the most important part of any column family. So primary key is a column or set of columns. It is not like key. You can have a single column also. If you take our example, we have a primary key as a user ID. Correct. So, sorry, primary key as a user ID, ISO country code, attribute name, and all these stuffs. Similarly, somewhere I just created uh, these two as a, you can have anything here. So basically, coming back to this part, so there are two parentheses if you observe. The bigger parenthesis is the entire primary key. Then I have identified a smaller parenthesis, which is the partition key here. So primary key consists of two parts. One is the partition key and another is the clustering key. So primary key, basically the functionality of primary key is to determine or tell Cassandra that how you will store, how you will distribute my data and how you will store it. So if you see in a distributed data structure, if you have some data and you go to Cassandra, please save it. You will first know that where you need to distribute this data across all the nodes. Once that thing is identified, it will be identified with the help of partition key. Once it is identified, then you will go to that particular node, and then you will store that data in that particular node. At that time of storage, there might be some specific way you want to store it. That is determined by the clustering key. So clustering key is optional. You can have it or not have it. It depends on you. If you want some retrieval, some quick retrievals within the node, then you can have some clustering key defined internally. So partition key distributes the data. Clustering key identifies how that data will be stored. Any doubts till now? Any doubts till now?
Can you explain again this part keys, basically primary and cluster one?
So primary key will be distributing. Primary key will have two keys: partition and clustering key. I will again go in details of that. So partitioning key will be distributing your data, and clustering key will be identifying where data will be stored.
Okay.
So now, if you see each node which is present in Cassandra, each node will have a unique tokens associated with it. So try to visualize that you have a ring now. On that ring, there are nodes placed, and now within each node, you have specific ranges of tokens. Tokens you can think of just like an integer, some number is there, and which is the part of partitioner. Now it depends on whether it is a single data center or a multiple data center. Based on that, partitioner will distribute certain range of tokens to each of the node. Just let's limit our visualization to a single data center, which means single ring is there, and just visualize that three nodes are placed on that single ring. And let's say we have a token range of that token range is pretty big, but just for our understanding, let's take we have a range of 1 to 30. So node 1 will be provided 1 to 30 tokens. Then node 2 will be provided, 1 to 10 tokens. Node 2 will be provided 10 to 20 tokens, 11 to 20 tokens. And then node 3 will be provided 21 to 30 tokens. Okay. And with the node, each node has a property. So basically, if you go on the cluster and you ask for the properties of a node, so there will be a one property associated with each node, which will determine the initial token, which will determine the initial token associated with that particular node. And there's a partitioner which is responsible for generating tokens. So now this particular partitioner, whenever any request comes, so it will randomly pick the coordinator node now. Once the coordinator node is picked, so the request will have a partition key to it. So that partition key will be passed to partitioner. It will return you some token. With the help of token, the coordinator node will identify which node is having this data. And there's a replication factor also. So replication factor is nothing but once you are persisting any data, it is also replicated across multiple nodes in order to identify basically in order to have a better availability. So replication factor will be replication placement will be determined by a replication placement strategy associated with that particular our cluster. So now basically we have a coordinator node which have a token. With the help of partitioner, it will identify the token. So this token, with the help of this token, it will ask the replica placement strategy. What are the possible, what is the actual node he know with the help of that token, and with the help of replica placement strategy for this node, it will identify what are the other replicas where it resides. And then one major part of it is, so now it know where to go. So the distribution, how data will be distributed is completed. That is a known fact now using these variables. And one more important thing is ki in Cassandra, the raw data is not segmented across nodes. So if you see that this particular row will contain a lot of columns, correct? A lot of these blue line, this blue line is called like a one row, you can visualize it as. So all the data for this particular row, all the columns for this particular column family will stay together. If I take a single row, that entire row will not be segmented across multiple nodes. Entire row will exist on a single node, or it will not exist on that node. Now coming back to the partitioner, so basically there are three partitioner which we can decide how we will distributing our data. First two partitioner, the performance wise, functionality wise, more or less both are same. Performance wise, Murmur 3 partitioner is better. It uses Murmur 3 hash instead of MD5 hash. The third one is little bit different from above two, but it is not recommended to use. Third one basically provides some sort of a aggregated queries or range query. There are ways to execute range queries using the above partitioner also, but byte order partitioner supports it to a very exhaustive use cases. But what happens is if you are supporting, if you are distributing data with the thought process of supporting aggregate queries and range queries, then what happens is, let's say I have a lot of data. I'm storing like mobile books and everything. So if you are storing it for the aggregation or range queries, it might happen कि same sort of data might be limited to a same node. So we'll expose the hotspot on that node, and also it will be difficult to balance the load now. So whenever request is coming, it have to go to that specific node. So load balancing is impacted, and that node will become a hotspot. For example, like some book related sale is going on, let's say, and book related data is concentrated on a specific node, then all the load will come on that node. So that will act as a hotspot and mm, might uh, impact the performance of our system. It is not recommended much. It is also like in a deprecated stage. So we will be going ahead with Murmur 3 partitioner. So the queries which you will use using partitioning key, it will be just a simple SQL query. I don't have right now, but yeah, just visualize a simple SQL query. Now you have a where clause. So first in the SQL query, you select something and then you provide the restrictions behind the where clause. Ki where X is this, Y is this. Now, when you are using partition keys, all the columns of a partition key should be or like must be present in the query. It should be restricted. Restricted is the way of Cassandra terminology. So you will restrict the partition keys. The reason behind, if you don't restrict the partition keys, all the partition keys, because all the keys are required to generate the token, it will go to the token generator there. So if you don't have any of the primary, any of the column, so primary key can be part of multiple column. If you don't have any of the column in which is acting as a primary key, sorry, which is acting as a partition key within your primary key, will make your query to read the entire node, read the entire data present in your column family, entire data, because it don't know where that data resides. That partition key determines key where that data is residing, so it will go to that node. If you are not able to identify that node, then it have to do a full table scan, sort of full column family scan. So Cassandra also help you in a way wherever Cassandra feels these restrictions are violated, your query will fail. So these restrictions you have to keep in your mind whenever using these will expose your query to fail. You will have a message also to understand that, but yeah, your query will fail if any of these four things are not taken care of. All the partition keys should be in the where column. You can use in query and equal to operator on your partition key. For example, like user ID equal to this or user ID in this, where like if I take about our use cases, select dash 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 where user ID in some list or user ID is equal to some value. We cannot use this equal to or range to operation. Again, the reason being the same. You don't know where the data is distributed. You cannot predict that, and you cannot generate the tokens also. You don't know, because in order to generate those sort of tokens, you have to first fetch the data. What are the possible keys which are there? So there's a way to use range query, which is you use a token function, and that token function will generate some token. Then you can use range query on that value which is output by token. Then whichever node is holding credibility of token greater than that will be traversed. But again, that is not a performant operation. Yeah, tell me. Devesh.
So Amit, I think native Cassandra supports the where clause without partition keys also. Only the Astra DB has this restriction.
No, any key, everyone support. Only thing is you have to extend that query with some allow filtering or some clause. The reason being is ki, why you are scanning your entire table. If the logical reason of limiting it is, if you don't know where your data is distributing, where your data is living, without that partition key, you have to scan the entire table to retrieve that information, which is not recommended thing to do anywhere.
Got
So
it.
yeah, that is the main reason behind it. Here also you can get like all those support with some extensions to your keys where you say key, it's okay, whatever it happens, just do the full table scan. So they are keyword for that. I think it is allow filtering most.
Yeah.
So now coming to the clustering key. Now you, with the help of partition key, first you know where your data is distributed. Now with the help of clustering key, so the if you go again to this part, so this within two braces is my partition key. Okay, this will tell me where my data will be distributed, and the second part will be a uh, clustering key. It will be removed. I will remove it. I am changing this to map now. Or yeah, we will talk here. We can discuss sometime later about that. Now coming to the clustering key, the columns which are present in primary key representing clustering key will determine how the data will be stored on the disk. So in a single node, if you visualize it, so you have a PK1 as your primary key. So that will determine that I have to go to this particular node. In this PK1, your data can have clustering keys. So CKA1, CKA2, CKA3 like that. Correct. After that, uh, as many as you have, it will keep on sorted order. So if you see CK1, CK2, CK3 is there, then behind that, the second one is also in the sorted order. So it will be in that particular format. Once these three are identified, then the rest of columns will be replicated. Got it? So the rows are sorted by the values of clustering keys by one column, and then you can retrieve the other columns. So if you see now here, so over here, my user ID attribute ID will be there, and then everything will be repeated. So for this particular, for our use case, our most of the columns will be repeated a lot, which will be a waste of disk. And again, I'll discuss that part. We can take a call there. Uh, Moving to now restrictions on clustering keys. So now clustering keys basically, first of all, whenever you define the clustering key, that ordering is very important, whatever order you put here. Okay. Whatever order you put here. In the same order, you can create your queries. You have to write queries in the same order. Okay. So the restriction you will put on clustering columns must be in the same order it is as it is defined in the primary key. And the reason being again, the performance issue. If you try to logically evaluate, if you don't know the middle part, then you have to scan it a lot. So by default, all those kind of queries are uh, validated and failed in the in your console, or what in your in the Cassandra. So you will be getting error. Again, if you the same thing, if you want to put some restriction on the nth clustering column, then there must be restriction present on 1 to n minus 1 clustering column. And similarly here, in and equal operators are supported on clustering columns. Clustering columns also support range operators. Uh, 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 yeah, I have not written here, sorry. So hopefully this primary key is now clear to everyone. Moving to the consistency part. So consistency for Cassandra is sort of tunable here. And when I say tunable consistency, so we have these type of consistencies which are supported. One, or let's talk about write consistency first. So write consistency is like number of replica nodes on which write must be succeeded before returning the success to the client. So over here we have one all quorum and local quorum. So as it is mostly self-explanatory, one is like a single node is enough to tell you that your write is complete. Then all is like all nodes. And then quorum is you determine what is the quorum, then it will be waiting for those many nodes to uh, tell you back that this is completed, write is completed. And local quorum is basically is used when you have multiple data structures. So quorum till quorum, it is like a single ring is, so single ring is there, then single ring will determine a single data center. Then if you have two data center, you have two rings. And if you have a quorum there, then it will ask for two nodes in the first ring, then again two nodes in the second ring. So it will be very heavy. So it will be very it will be non-performant. So in those scenarios, you just wherever it goes, you just ask for the local quorum. Whichever data center you have written, you just ask for local quorum within that, and then let Cassandra write it back asynchronously. The thing here is, if you are writing data and any node is down where you need to write that data, because coordinator node can be anyone, then based on the partition, you know where I go, where I need to go and write it. So with that primary key, you identify the partition columns, and you generate a token and you go to that node, and that node is not there. Now what you will do? So now in that scenario, again, it have the replicas also, it will write to the replicas, but again, that node is not there. So for those nodes, the coordinator node will keep a hint file. And that hint file, basically, it stores that data. Default value for it is 3 hours. It will maintain that hint file for a given node. And after till 3 hour, it will wait for that node to come back again live. By node, I mean the node which is responsible for those tokens. They talk within themselves, all the node gossip protocol they use, so they will be knowing someone is there or not there. That you don't have to worry about. You can just configure it, but internally they knows. So once is the within the time determined, if that nodes come back, it will write it to that node. So it will just put whatever is in the hint file to that node. So yeah, post that it will be paused. Otherwise, default time breached, it will be paused again. Now coming to the read consistency, again the definition is straightforward. Number of replica nodes you want to check before returning the data. The same four parameters are there, but it do it little bit intelligently. So whenever a coordinator node is selected, they Cassandra run a snitch program. What that snitch program does is Cassandra, that coordinator node knows out of the once you have that partition key, you know what is the node where that data is present and what are the replica nodes for that partition key using your replica strategy. So you know all the nodes. Let's say our replica strategy is three, so you know all the three nodes which basically have that data. Cassandra internally runs a snitch program. So this snitch program will tell you who is the fastest node. Within these three nodes, whoever is the fastest node, coordinator node will retrieve the data from that node. Okay. And to the remaining node, it will say, ki send me the hash of your data. Don't send me the data, just send me the hash of data. So whenever the data comes to the coordinator node, at that time, coordinator node have a data from the fastest node. It will take a hash of it and it will compare with the hash provided by other nodes. So it will quickly retrieve the data. So now if hash is not matching, what happens is there is a concept of a read repair, which coordinator node will perform to resolve the conflict. If basically the data is not updated in replica node and read request came and then you find out that hash is not matching, so coordinator node will perform the read repair. What it will do is based on timestamp, it will do some magic and then it will tell that node ki update your data with this information. So this happens background asynchronously. You don't have to wait for your read request to come. It will be given immediately. Based on timestamp, it will just resolve whatever is the best thing and then it will send it. Now, this is also configured property. What is the read repair frequency you want? Usually it should not be high, otherwise it will consume a lot of bandwidth. It is limited to lower frequencies. So that is the one thing. Otherwise, your cluster will be busy within itself. It will be hard to identify what is the issue. The load will not be much, but internally it is just running blindly across read repair. For this part, replication factor and quorum, just a standard thing here. So quorum is just like replication factor is at how many nodes you want to replicate your data. Ideally, like based on AZs and all, usually 3 is the recommended replication factor. We will be going ahead with that only. Then quorum is just identified with the help of sum of all replication factors, read plus write plus 1 divided by 2, which will be 2. So we will wait for 2 nodes to let us know. Here one question is there. I'll just let you guys know. Might be discussing with the data stacks team. For us, we can reduce the read quorum to so basically read and write both quorums are 2 here in ideal scenario. But for our use case, I was just thinking, why not we make our so basically to keep the consistency, this particular mathematical formula should be basically uh, uh, always respected, which is read quorum plus write quorum should be greater than replication factor. So that means you will one read and write tool will always retrieve you the right information using this particular uh, equation. So I was thinking if we can have our read quorum to 1 and write quorum to 3. So our writes will be little bit slower. It have to write to all the 3 nodes. But our read will be very quick, instantaneous, and on top of that, our consistency will also be very high. So you guys also think about it. I was thinking of this experimentation.
Consistency will be low, isn't it, Amit? Read would be.
Consistency will be high now. You have your data written to everywhere first. Your data is present at every node. You are
Okay,
writing to all the 3 replica places, na?
got it.
So consistency will be uh, consistency is like everything,
Yeah.
like highly. Now we will come to little bit interesting part. So now we will see how data is stored in the Cassandra. Okay. So this is the picture for one node. So if you take any node, what are the things which are present in one node at a very high level? These black dotted line is determining those 2 things, correct? Any machine you pick, there will be disk and there will be memory associated with it, correct? Correct. बता दिया करो भाई, पता ही नहीं पड़ता मेरे को लगा बीच इंटरनेट डिस्कनेक्ट तो नहीं हो गया. सो मेमोरी और डिस्क होगा, करेक्ट? यस नो तो बोल भाई.
Yes.
हाँ, तो इसमें नाउ इन memory the advantage is it is super fast, it is immediately available. Disk is like, the advantage is it is persistent. If server goes off or electricity goes off, it data will not be lost. So if you see Cassandra, so Cassandra have 3 main component. One is mem table, one is commit log, one is ss table. And mem table exists in the in memory, whereas commit log and ss table exist in the disk. There are certain exceptions here and there, but that is the high level overview. What will happen? The journey of write will be, let's say, uh, Ritvik just requested a write in Cassandra. So first of all, that request will identify the node. Once the node is identified, it will come to that node and it will update the commit log. Once commit log is updated, then data will be moved to the mem table. When mem table is updated successfully, then node will Cassandra will tell to Ritvik that your write is successful. Now you just go and enjoy. Correct. Now what will happen is internally, asynchronously, at some point in time, based on our configurations and all, data from mem table will be flushed back to the ss table, and ss table is where it is persisted permanently. Now we will go through each of these component one by one. So first we will go through the mem table. It is simple to understand. Mem table is in memory hash table. It is just a in memory hash table, and data will be lost if node is crashed. And over here, one column family can have multiple mem tables. It is not like one column family. So what was column family? You guys remember? Can anyone tell me? What was column family you were talking about? बता दो भाई.
What is the question, Amit?
Yeah, I was asking like, what was the column family we were discussing?
Table name only.
So column family is a one table which we have logically. So over here physically one table can be mapped to a multiple mem table. It is not like for one table you will have one mem table. Okay. So it is just a in-memory hash table, and it stores your data in this particular format. Row key is the primary key which is identifying that row, and it is just a column value pair for that particular row. So that's mem table. Commit log is a little bit trickier than this. So commit log is a
Just one
memory.
question, Amit. So when data syncs, like basically from mem table to disk, uh, like it happens on a particular duration or based on the mem table's fill rate?
It do lot of magical activity. We'll cover it. It is like
Okay,
not
okay.
that easy to explain immediately, but later I'll cover it.
Oh, okay,
It is like a little bit complicated.
okay, okay.
So over here, what happens is commit log is just a memory mapped log file which is present on the disk. So when I say memory mapped log file, what that mean is key it is some segment of virtual memory is there which is having a file resource and which is basically acting as your commit log. So basically some virtual memory segment you can identify, you can visualize that will be having your file resource, which will be just like a append only, basically not append only, yeah, append only logs. It will be committing to that particular file. So it's a virtual memory. So in every 10 seconds, it will be synced to the disk. So it will be your write are very super fast. Whenever you don't have to wait for it to persist on the disk. So, but this 10-second is the window. So this is a default value. I guess it is also configurable. But this is the value where if your node is crashed, then whatever data is there for 10 seconds before that might not be able to recover it. So yeah. So it is stored this, what it stores in this file is whatever action is taken on that particular piece of disks. Like Ritvik updated his profile with some hobbies, and then Ritvik updated his profile with his last name, or he updated his profile with email. So these all actions are persisted on the disk in append only mode, and every 10 seconds it is flushed into disk. First of all, it keeps it in a virtual memory where a file resource is present, and then it will sync up every 10 seconds. And this particular file can be used to recover the data. Any node is crashed, then you can just replay this commit log, and that particular mem table will be recreated for you. So now coming back to the SS table. So SS table is sorted string table. It have four component to it. Four component. Try to visualize it. It is very simple, but it is a little bit complex, but very logical process. If you want to have how those things will be persisted, and basically like if you take SS tables, so there is index file, there is summary file, there is data file, and there is Bloom filter. Okay. So if you have these four variables, how you can easily so for example, like let me ask one question. Okay. Let me ask one question. Key, if you guys basically want to retrieve the data quickly, let's say from your book you want to retrieve some information quickly, or you want to reach that information quickly, how you will, what are the things you will need to find that particular location? Any guesses? Anyone want to take a
Indexes.
what?
indexes.
Okay, so let's take an example of book you have indexed.
Then we'll go to a particular page and then probably search from top, linear search mostly.
Yes. So now Cassandra just like refined that particular process more efficiently. So what it does is, first of all, it have an index file. So index file will hold the location where a row is located, just like your index present in your book. Where a data file is the main player here. So index file will hold the location where for particular row key this row is located in the data file. It just act as an index, and these entries are sorted by the token is basically whatever partition key you have with the help of your this thing tokenizer. You will generate the token for that, and yeah. So now that token based sorted based on token is just a replication of your partition key. So yeah, partition key is one part of a primary key, correct? So based on that, it is ordered. Now, next, what it does is every SS table will have one index file which is associated with it, only one index file. And this particular file is residing on the disk. Okay. So SS table have 4 component, index file is residing on the disk. Now the next component is a summary file. So
One
summary,
question, Amit. So for index, so for example, in a particular table, I want to index on multiple fields. So necessarily, I want it like I would require to add it as part of partition key, or I can separately just have an index on it without making it a
partition key. So basically, the index is what? If you take a MySQL index, is just like a B plus tree, where
right.
where the data is stored.
Right.
That's why internally going into the data structure. If you have a primary key, that is your index, correct?
Yes.
Primary key is acting as your primary index. Then there's a concept of secondary index. I might have skipped it here knowingly. We can discuss again on it. I just was not planning to cover it. It is not
Okay.
much preferred. But if you take your primary key, that's a primary index. Now it have two part to it. One is the partition and one is the clustering. So partition key is determining where your data is there, and
Right.
clustering determining how it should be ordered when persisted on the disk.
Hmm.
Correct. So clustering key is determining how you can quickly retrieve that data. So
Got
if you take that way, so once you reach that node, then you can quickly retrieve your data with the help of your primary key.
Okay. Okay.
But identification purpose, partition key plays important role. So this index file also reside on the disk. So now let's cover the second part of it. So second part of it is the summary file, and summary file is basically a summary of the index file. It is a summary of index file. If you want to quickly look up into, if you guys remember, there was one algorithm we used to read when we changed the companies. That is binary searching, correct?
Yep.
So binary searching is just like what? You just limit your search space, correct? You know that this is the start and end, and in this range it is residing. Then you divide it into two, then you identify in which range it is residing, correct?
Right.
Correct. So it's like a example for the summary file. So summary file, if you see, this is the summary file on the right side, and left side is the index file. So if any request come, you can just quickly look up into summary file. You know from the summary file what is the range I have to go through, and you can then quickly limit yourself to that particular range. So that particular range is the interval of summary file, which is limited by index interval. So if you determine the index interval property in your column family have one more property which is index interval. So this will help you in sampling the interval. Just give me 1 minute. Yeah, sorry. Basically, index interval will determine what is the interval we are using in our summary file. Okay, and then basically summary file will be used to first identify the location in index which we have to retrieve. So this is the index file. So index file is condensed into the one entry of your summary file. So from summary file, you can just limit the traversal in your index file. So just like a index of index. Now the third part comes the Bloom tree, Bloom filter. So Bloom filter is, I think I just also shared with Ritvik also once. So Redis also support this thing which we can use. So basically Bloom filter is a data structure which is very famous in a lot of databases, like in our MySQL also there is a Bloom filter available. So what it helps us is it helps us identifying whether that particular key is present in my database or not. Okay. So in this particular Cassandra example, it will help us identify whether that key is present on my disk or not. So it is just a basically probabilistic data structure which hashes and then mark those hashes as true or false. It can have a false positive. You have a key which is converted into a hash and then it is looked up, and that particular hash value was created from some other thing. Then there can be false positive, but it will definitely tell it is not if it is uh, so basically false positive can come. You got it, or I have to explain it again? You got
Like
that?
I have an idea of Bloom filter, but I think you can explain it again. Like, is it clear for everyone else?
Yeah, it is clear for me also.
So basically, I think this is the part you can read. It can identify with surety that key is not present. But if key is present or not, it can have false positive. But if it is not there, then it is for surety. So basically, like what the problem we were having in Redis key, if key is not present, again we are going there. So with the help of Bloom filter, we can limit that. Key is not present, then we will definitely tell.
Okay, yeah.
So this particular part resides in memory. So that's why I was saying in SS table we have 4 component. Bloom filter resides in memory. Other 3 resides in disk. Basically, it is helpful in memory only. It can identify here with some probability. This probabilistic model can be controlled based on the degree of, basically it just stores basis on the bit. Based on that particular length of your data structure, you can make it very bigger. Then your probability of telling it is very high. So as your probability increases, it becomes less useful for Cassandra, because then it is basically just a replication of that particular thing. Yeah, now coming back to the main part, data file is where actually your data is residing, and all the columns will be associated with the rows are present on this data file. How data file is consumed? It is consumed in two steps. One is disk seek to access the right row. Then it will perform the sequential read to access the columns in that row. And within, so first is the Bloom filter. We were talking about the SS table. Now for data file, it will have again data Bloom filter, which will identify what it was doing for rows. Data Bloom filter will do for the columns. So if you take this particular visualization, this is your index. From your index, you go to the data file. Data file, first it identify the partition key, and then it sequentially read all the columns, and it uses Bloom filter to identify what are columns it has, so that it can just optimize the operation of reading. So data file is where the actual data is set, and in data you have, with every column, you have column name, column value, and then the column timestamp. So this timestamp is used at the time of your what we are discussing, read repair. So to identify which is the updated value for this column, and if this is provided by you, it is okay. Otherwise, Cassandra update it automatically by himself. And this data file have the actual data in the form of column value pairs. Now let's come to our main slide, how actually read and write is happening. So first of all, in this particular diagram, we have two more component added. My slide is visible. My screen is visible.
Yes.
हाँ. So commit log हमने देखा, मैम टेबल हमने देखा, we know Bloom filters, we know index table, we know data table. With the data table, we have column Bloom filter, and we have an index summary also. Index summary is residing here. ठीक है? Index summary was the summary of your index table. So summary table, index table, data table, Bloom filter, मैम table, commit log, और दो और आगे हैं, which are key cached and row cached. These are basically two properties of your column family. Column family was your table. These properties determine what are the rows you want to keep as a cache. Just it will be acting as like a Redis only here. So you can cache certain keys in memory, and you can cache certain rows also. There is some default value, and you can fine tune them to identify what are the keys you want to cache and rows you want to cache. And there is one more property with column family, which is preload these caches. So it will preload these values based on some configuration you will provide. There are a lot of other properties also. So now if the write request come, let's first go for write request. Write request come, Ritvik is updating his profile. Then first of all, it will come to your index summary. Then from index summary, it will identify the index table. From index table, first of all, it will come to the commit log. First, it will come to the commit log. Then in the commit log, it will come and write it. Then immediately it will update the mem table, and then it will return it as a success to Ritvik. For Ritvik, it is done. But internally, what happens is it performs some, based on some configuration, it do the compaction also. So whenever mem table is full, it will be after certain interval, based on defined interval, it will be flushed into the data table. When it is being flushed into the data table, it will retrieve the index summary. So basically, Cassandra want to flush the data quickly as possible. So first it will go to the index summary. Then from index summary, it will first basically it will identify कि from Bloom filter कि वो table वो वाली row है कि नहीं है. Based on that, it will know कि I have to create a new entry or I have to update it. ठीक है. फिर it will have index summary also if it is updated. So for index summary, it knows key what is the range, what range of index I have to traverse in my index table. Then it goes to index table, and then from table it identify the location on the data table where that particular table is present. And when it have identified that table, then it will basically retrieve that particular location, and it from the column bloom filter, it will identify the columns it will request for in the memory, and then it will retrieve all those columns. One more thing will happen is before it will sorry when it is entering into commit log and updated in mem table, it will also invalidate the row cache automatically. Row cache and key cache automatically. Yeah. Any doubt here?
No, I think it's clear for me.
ठीक है. Now let's go for the read. So whenever you are doing read, it will go for key cached. It will just retrieve that key and all. First of all, it will retrieve from these caches. If it is present in the caches, then it is good. Otherwise, again, it will go to index summary, index table, and data table also. Then it will confirm with the mem table, and then it will return it. I am confused in the ordering of mem table and data table, but mem table will have updated data. But I think some delete in the scenario of delete, some potential error can happen. I think the order is from index summary, index table, then comes to data table, then confirm with the mem table, and then return it. So this is your read. Any doubt here? Any doubt here?
Are read requests also persisted in commit log?
Why you will persist read request, bro?
All right. Okay.
What you will do? Nothing will be coming there, no? So it is of no use, no? Commit log is basically a quick way to persist in the disk without manipulating your uh, physical disk storage, without manipulating the physical location on the disk where that data actually reside. You just put it in commit, so it is secured in case of failure. Then it goes to mem table just to update it quickly, so that all the compaction activities it do in the mem table.
Okay.
There's a tombstone. Tombstone is just like the actual meaning of tombstone is also you just put tombstone there in telemetry. So here also, whenever something is deleted, just Cassandra goes and put a tombstone on that particular row. It does not delete it. So it will be marking it as deleted, and there is some logical reason for it to not delete it immediately. I don't remember it. I forgot now. But there is a property GC grace second. This property determine how long this tombstone will reside, and why we need tombstone instead of directly deleting. Yeah, I remember. It will avoid the ghost data. So ghost data is basically default value for this is 10 days. Ghost data is basically sometime it can happen that if I go to this thing, it can happen that data is deleted from your table. Data is deleted from your table, and then compaction. Some activity happens. Compaction or commit log. Something fails. Then that data. Sorry. Yeah. Data is present in your table, and in commit log or basically mem table, commit log is flushed into mem table, and some disk fail while writing this data, then that entry might got away, and that data will remain as a ghost there always. Some server failure at here or here, कहीं पे तो एक जगह होता है वो याद नहीं आ रहा, तो वो ghost डाटा बन जाएगा, फिर कभी डिलीट नहीं होगा. So इसको थोड़ा इसीलिए we keep it a little bit longer. So number of SS table, now coming back to SS table. So these are our SS table. So number of SS table which exists on node is determined by the min threshold. So these SS tables basically are physical. These are the physical existence of our data. So whenever this min threshold breaches, so what Cassandra does, Cassandra do the compaction activity. So all those fragmentations and everything goes away, and disk is optimized for reads. So it merges whenever after certain limit these number of SS table increase. So SS table have some size and all. So based on that, it will perform the compaction activity. This is a very important property, should be evaluated properly when setting up your cluster. And this gossip protocol, we were saying, these nodes keep on gossiping with each other to identify the state and mark it with certain version, and that version will be used to know certain information about the node, whether it is alive or not, who is faster, who is slower. So all those things they keep talking to each other, and this is what they used. Whenever someone is available, they will hand over the hint file to them. If they are not there, then it will be parsed. तो यार हो गया खत्म, अब कुछ हो तो बताओ. Any doubts? Otherwise I'll close the session. How to stop recording? ठीक है, कोई क्वेश्चन है तो बताओ, वरना स्टॉप रिकॉर्डिंग कर देता हूँ.
I think I'm good.